Hello friends, I am Professor Rajendra Koranne from my channel Teach Easy. Up till now, we saw how to calculate moment of inertia of solid symmetrical sections, hollow symmetrical sections, structural sections such as I sections, T sections, channel section, angle section. Today we will see how to find out moment of inertia of triangle, that is triangular section. Okay, so for that let us take the example. A triangle ABC with base BC and apex A have measure of angle B equal to 90 degrees. If AB is equal to 90 mm and BC is equal to 75 mm, calculate IXX, that is about horizontal centroidal axis, IYY, that is vertical centroidal axis, IAB, that is the vertical side, and IBC, that is the horizontal base. So let us draw the figure. This ABC is a triangle, BC is base which is equal to 75 mm, AB is height which is equal to 90 mm. It is given that measure of angle B is 90 degrees. So this is right angle triangle, and for right angle triangle we know that we can very easily find out the centroid, and for that the centroid of the triangle is at h by 3 from base. So for this particular distance, this will be height by 3. What is height? 90. So this will be 30. Do you understand how it is 30? So remaining distance will be 90 minus 30, that is 60. Similarly, if I say that YY is the vertical centroidal axis, this particular distance will be this dimension divided by 3, and BC is equal to 75 mm. Therefore, this distance is 75 by 3, that is 25 mm, and definitely the remaining distance will be 75 minus 25, that is 50 mm. So this we already saw in applied mechanics, that the centroid of the triangle lies at h by 3 from base or 2h by 3 from apex. So here h is equal to 90, so h by 3 is 30, so this is 30, and 2h by 3 is 60, so this is 60. Now we have to calculate the moment of inertia about x-axis axis, y-y axis, about side AB and about side BC. Now for IXX axis and for IBC, this will be the triangle for which this will be base, that is 75 mm, and this will be height, that is 90 mm. On the other hand, when we want to calculate IYY or IAB, at that case this will act as a base. So base will be AB is equal to 90 mm, and this distance will act as a height, that is BC is equal to 75 mm. Now we already saw in our lecture of standard formulae moment of inertia of a triangle about centroidal axis is given as B into h cube divided by 36. Okay, so let us write first for IXX. Ixx is equal to B into H cube by 36. Now for Ixx, B is 75, H is 90. So it will be 75 into 90 cube divided by 36. And this value comes out to be 1.52 into 10 raised to 6 mm raised to 4. Now let us calculate Iyy. This is your yy axis. For Iyy, this will be base and this will be height. So again formula will be same. Iyy is equal to B into H cube divided by 36. But mind well, now B and H have interchanged. So now for Iyy, B is 90 and H is 75. So it will be 90 into 75 cube of that divided by 36. This comes out to be 1.05 into 10 raised to 6 mm raised to 4. Now let us calculate IAB. Now what is IAB? I about the side. We know that moment of inertia of triangle about the base is BH cube by 12, and for IAB base is 90 and H is 75. So IAB, I will write the formula. Do not confuse in between B and H. For that purpose I have separately written over here. So it will be B into H cube divided by 12. What is B for IAB? B is 90. H is 75 by 12, which comes out to be 3.16 into 10 raised to 6 mm raised to 4. Now the last one which we have to calculate is IBC, that is moment of inertia about base. Definitely the formula is B into H cube divided by 12. Now for BC, base will be 75, height will be 90 divided by 12. So this you will get as 4.56 into 10 raised to 6 mm raised to 4. Now this is how we have calculated Ixx, Iyy, IAB and IBC. Now one thing you have to keep in mind, as this is a right angle triangle, when you will turn it through 90 degrees, this will become base, this will become height. So depending upon the disposition of the triangle, you have to select the height and base. For this triangle, this will be base, this will be height. If you turn this through 90 degrees, this will become base and this will be height. So in this manner, we can calculate moment of inertia of a right angle triangle about x-x axis, about y-y axis, about the side, vertical side, and about the base. Do you follow this? In the similar manner, using parallel axis theorem, you can also find out moment of inertia of this triangle about the horizontal axis passing through apex. Okay. Let us take second problem of triangle. Take down the problem. Calculate Ixx and Iyy of an equilateral triangle of side 40 mm. Also determine radius of gyration. Now let us draw ABC is an equilateral triangle. What do you mean by equilateral triangle? All the sides AB, BC and CA are of equal length, that is 40 mm, and all the angles are 60 degrees, that is known as equilateral triangle. Now from this triangle, if I drop a perpendicular from the apex, AD is drawn. So for this particular triangle, I can say that this is the base and this is the height. And to calculate height, consider triangle ABD. From this triangle ABD, sine of 60, sine is opposite side upon hypotenuse. So opposite side is AD upon hypotenuse is AB. We know that AB is equal to 40 mm. So from that we can calculate AD, which is the height, which will be AB into sine 60, that is 34.64 mm. Do you understand this? Now for this particular equilateral triangle, you can very easily see that this triangle is symmetrical about y-y axis, mirror image. Okay? This is x-x axis, which will be at h by 3. And this is y-y axis. So let us first calculate Ixx. So what is Ixx? What is the formula? Come on, can you tell me? Ixx is equal to B into h cube divided by 36. Now what is B? B is the base, that is BC. Okay. So I will write it like this so that you will understand it. BC into h cube. What is h? AD cube divided by 36. Substitute the values of BC and AD. What is BC? BC is 40. AD we have calculated 34.64. Cube of that divided by 36, which comes out to be 4.62 into 10 raised to 6 mm raised to 4. So this is Ixx. Direct formula. You have to just understand what will be B and what will be H. It will be simpler to calculate it. Just substitute in the standard formula, calculate the answer. Now, let us calculate IYY. Now for IYY, you have to understand one important thing. See, look here. Just now I have told you this figure is symmetrical about YY. So may I say that this IYY will be moment of inertia of triangle ADC about the side AD multiplied by 2, because these are two triangles. Do you understand this? Therefore, see, look here, I will write it. IYY is equal to 2 into bracket. Why 2 into bracket? 2 times. This is mirror image. 2 times mi of, look here, of triangle. Which triangle? ADC about vertical side AD. This is important to understand. This is the right angle triangle, this is right angle. So moment of inertia of this triangle ADC about base multiplied by 2 will be IYY. Okay. So let us write these details. 2 into bracket. What is mi of triangle about base? It will be BH cube by 12. Now what will be B here? Because we want to calculate about AD, B will be AD and H will be DC. So B, that is AD, into H cube, that is DC, cube of that, and divided by 12. Substitute 2 multiplied by, what is AD? AD is 34.64. What is H? DC is 20. Cube of 20 divided by 12. If you calculate it, you will find that this value will come out to be 4.62 into 10 raised to 6 mm raised to 4. Okay, so this is IYY. If you look carefully at IXX and IYY, you will find that for an equilateral triangle, IXX is equal to IYY. Okay, so that is very important thing I am writing. For an equilateral triangle, come on, IXX is equal to IYY. We are also asked to calculate the radius of gyration. So what is radius of gyration? It is under root of I upon area. So this is very important one. So radius of gyration, first we will calculate the area. Area. What is area of triangle? A is equal to base into height, base is 40, into height 34.62, 64 sorry, half into base into height. This is area. So you calculate this area, and this area you can very easily calculate with the help of scientific calculator. Okay. Then you know that Ixx and Iyy are same. Therefore, radius of gyration about XX axis and about YY axis will also be equal in this case, because Ixx and Iyy are equal, is equal to under root of I upon area A. If you substitute the value of I and the area, you will get the value of Kxx and Kyy is equal to 8.16 mm. In this particular lecture, we solved the two problems of triangle. One was right angle triangle and one is equilateral triangle. For equilateral triangle, you have to keep in mind that Ixx and Iyy are equal. Therefore, Kxx and Kyy are also equal. I think you follow these two problems of triangle. Thank you.